Hey, Fiona.
Wow, are we the only ones with scooters in this room?
Whoa, looks like it.
Huh, that's a bit disorienting.
See, everyone, or almost everyone on MongoDB has a scooter, so we're used to seeing way more scooters around.
Yeah, that must have taken y'all forever to get here, huh?
Anyway, let's get started.
I agree. It's about time.
Today, we're going to talk to you about scaling your app with Atlas and all the horrors that come with having a successful application.
And this is us. I'm an engineer on the Atlas team. I like long scooter rides on the beach.
And I am Ian, known as the two-wheeled devil, and I work on the query team.
And the reason why we want to talk to you about scaling your app with Atlas is because we have an app that we indeed want to scale.
Believe it or not, very recently, we were both novice scooterers. I was riding this.
And I was doing even worse.
It was the most fun we'd ever had.
So we were scootering around the city of New York thinking, wouldn't it be great if we had a network of friends to scooter with at a moment's notice?
So we decided we'll just take matters into our own hands and create a social media app for people who use scooters. So the year's 2018, and we figured we'd start by making a prototype of the app and see where it goes.
And clearly we needed a place to store our user metadata, image metadata, friends lists, posts.
So we asked ourselves, do we need a database?
But setting up your database, your own database, can be kind of a pain.
You have to provision machines, start the database instances, and then monitor their health.
Luckily for us, we work at a database company, so we know about Atlas. With Atlas, your database is in the cloud and managed by us. Your application can connect to that database, and you can just configure it through our nice UI. Let's take a closer look at what that database looks like.
A replica set in MongoDB is a group of processes that maintain the same data set. Replica sets provide redundancy and high availability and are the basis for all production deployments.
Primary nodes are the only nodes that can perform writes in your database, and they're considered what is the absolute truth in your data set. Secondaries just replicate everything that happens in the primary.
If the primary crashes, your data is still around because it's on the secondaries. And if something goes wrong, the secondaries can always step up to take the place of the primary.
On Atlas, we have a free version of this database called the free tier. It's great for prototyping for apps with small loads.
The nice thing is it has the same API as a normal Mongo database. So if your application grows and you have to move off the free tier, you don't have to change your application's code.
The nice thing about it for us, though, as developers building a database or building an app prototype, is it's free. And by free, we mean free forever. It's not a free trial.
You're probably asking yourselves how we can afford to give all of you a free database. We have some tricks, and we'll explain them later. But for now, we'll just show you our pretty UI.
So let's show you how to make your own free database. So you're going to click Build a New Cluster on the Atlas UI, and you're going to choose a provider. For now, we'll go for AWS. And we're going to choose North Virginia region. And we're going to choose the M0 instance size to indicate that we want a free database. And you can change the name to whatever you want, except for that. And we're going to create a new cluster. And that was super easy. It didn't take too much setup time. And we've got a database to build our app on top of.
We pre-recorded this demo because, according to Murphy's Law, if we didn't, the Wi-Fi would go down or AWS would go down during the talk. We'll get to that later, though.
And here's our app. We're the only users on there, and there's only a couple posts. But it's a start. Got to fix some bugs. But we're feeling good about it.
Okay, fast forward to 2022.
Scooters have pervaded the tri-state area. Everybody's talking about it, and people are trying to use our app now.
And our own scootering skills have improved significantly. I can now break speed limits on a scooter.
And I can now do the hokey pokey on a scooter. After all, that is what it's all about.
So now that we have a slightly larger user base, the load on our app has increased. We're going to have to make some changes if we don't want it to crash.
Let's take a look at some of the limitations that the free tier has to decide if it's still right for our app. So first of all, on the free tier, all of your nodes must be in the same region. That means that if that data center goes down, not only your primary node goes down, but all your secondaries go down too.
This means your app would totally stop working until that data center went back up. For us, this is okay because we don't have that many users, but again, we'll talk about this later.
So let's move on to some of the other caveats on the free tier.
The free tier is built on top of a multi-tenant database, and so what that means is that the database storing your data is also storing other people's data at the same time. This is how we can afford the free tier.
To prevent all those different users from stepping on each other's toes, all client operations go through a proxy, which alters namespaces to make sure that there are no space conflicts.
This is all nice because it means that, like I said, we can afford the free tier, but it also means that you won't get the same performance as what you'd expect from a production level deployment.
Let's take a look at some of the metrics that we can examine on the Atlas UI to indicate whether or not it's time for us to move on. So here's a graph of the number of connections on the primary node of our database.
It looks pretty stable, around 50.
Yeah, while this does include internal connections between nodes, this is still kind of a lot for the free tier. Here's a graph of the amount of data transferred between your database and your application.
That does not look bad.
Nope, wait, I just crunched the numbers. That's about 7 gigabytes per week.
That's
a lot for the free tier. Is that right?
Is it?
And here's a graph of the number of operations per second performed on the primary node.
Looks pretty stable.
Yeah. This is kind of pushing it for the free tier, though. It's going about 150, pushing that limit. So something to keep in mind is that the free tier has some thresholds, and if your application exceeds any of those thresholds, your performance may be throttled in some way.
And if you approach any of these limits, you should probably move off the free tier. And we'll show you how to examine them in just a second.
Yes. You can take a look at these metrics for yourself on your cluster by clicking the metrics button. It's as easy as this, folks, on the cluster, and you're taken to this metrics page. So we can click whatever metrics we want to focus on. For now, we're going to go for the number of connections, the number of operations per second, the amount of data transfer, and database storage. And the nice thing about the metrics page is that we've got a graph for every one of the nodes for every one of the metrics. So we can have a pretty holistic idea of what the load on our database looks like. Oh. All right.
Okay, so clearly after looking at those metrics, we can tell it's time to get better hardware. It's time to upgrade.
It's time.
And in order to do that, we'll have to copy all of our data off the multi-tenant database, the free tier one, and put it into our own single-tenant cluster.
So first we're going to have to spin up our own single-tenant cluster, which requires us to spin up 3 different machines and start up our database instances.
And then we'll have to copy everything off the multi-tenant cluster, only the stuff that belongs to us. Go ahead.
Then we'll have to delete all the data that we had on the multi-tenant cluster, going through that proxy again so that the deletion is secure and we're not touching anybody else's data.
And then we'll put all of our stuff back onto the single-tenant cluster.
That would be a heart-pounding and anxiety-inducing experience to do manually. But luckily for us, fitting into the theme of clicking buttons on Atlas, this is pretty easy to do. So we're going to click Edit Configuration on the cluster, where we're taken back to this page. And we're going to go to the cluster tier accordion and move our instance size from M0, which was the free tier, onto M10, the smallest single-tenant cluster on Atlas. We apply the changes, and we're done. Oh my God. Here we go.
Okay, so now all of our problems with the free tier have been solved. But does this mean that all of our nodes are in the same data center?
I mean, yeah, you're not worried, are you? It's not like the whole data center of North Virginia has ever gone down.
Well, I was reading, and I saw this service event that Amazon had a few years ago.
Oh, that was back in 2012. Never mind. Much has changed since then.
Okay, I guess we'll be fine.
Oh, no!
Our worst nightmares have become reality. AWS North Virginia has gone down.
Bikers were seen riding away from the scene of the crime. By the time all the nodes went back up, our users were so frustrated with the app experience that they gave up scootering altogether.
To prevent this from happening again, we'll have to set up a cross-region cluster, meaning we'll have nodes in more than one region. To do this, first what we'll do is set up a new secondary in a different data center and take down the one in Virginia. And then we'll have to wait for it to copy everything that the primary has. That's called initial sync.
Yep, it's copying all the data, and it's caught up. It's officially an active secondary in the replica set. So next we'll have to do the same thing to the other secondary. We'll have to spin up a new secondary in a different region and take down the other one. Similarly, it's going to have to do an initial sync with the primary. And we've achieved what we want. It's alive.
A cross-region cluster. So now, what happens if, while we do this demo, AWS actually goes down?
I asked myself the very same question, and that's why I pre-recorded this demo too.
OK, so we're going to click some more buttons. We'll click the Edit Configuration button, which takes us to this page, which we've seen before. And then you toggle the cross-region switch. And then you choose which regions you want nodes in and how many nodes in each region. And that's it. Or
apply those changes. All right.
OK, so now we have a cross-region cluster. And if bikers attack one of our data centers, we'll still have 2 nodes up. And that's enough for our app to function and perform writes and everything.
All right, so once we got over that little crisis, it was smooth sailing until 2026. Scooters have pervaded North America. Everyone's selling their flying cars for scooters.
And we'll give you an update on our personal lives, too.
Since that's what you came here for.
I can now do some crazy jumps.
And I can now grind rails of all shapes and sizes.
And this is our app. We have users in Chicago and all over North America. I don't even know either of those people. This is great.
This is great. You know what's not great? Our users are reporting, dun dun dun, slow performance.
But how can that be? We just upgraded our hardware, and it's not like we have that many users.
Wait a second. Did we forget to create indexes on our database?
Oh no. We forgot to create indexes. You're probably all asking yourselves how these fools who work at a database company forgot to create indexes. But this is actually a very common problem for our users. It's no joke.
That's right. It's not a joke.
OK, so now we're going to explain what an index is and why you should care. So your app, or you might want to write an app which does a query that filters by certain field value combinations. For example, our app will probably run queries that filter by the username field in the users collection.
Right. So let's say that our app wants to run a query searching for a username equal to Alice. If we were to run this query without an index, our database instance is going to have to perform what's called a collection scan because we don't know where in the collection the Alice document is. So in this case, the Alice document is at the end of the collection. So our Mongo instance is going to have to examine every single document until it finds the one that we're looking for.
That sure sounds time-consuming.
It is. Back when we didn't have so many users, this wasn't so much of a problem because our collections were smaller, so collection scans ran pretty fast in general. But now that our user base has grown, the performance penalty is starting to show.
So to fix this, we can create what's called an index. An index is kind of like a special collection, except it only stores the values of the thing that we're indexing. So for example, an index on the username field will only store the values for username. Indexes are also stored in order of that field.
And every value in the index maps to documents in the collection that they represent.
So this means now that we have this index, when we look for the Alice document, first the database will look up in the index where the Alice entry is, and then
it will return the document from the user's collection that it's pointing to. Lookups are now much faster with indexes involved because indexes are sorted.
But we run so many queries against our application. How can we possibly tell which ones are the ones causing performance issues?
Well, it turns out that Atlas has a great feature for us. It's called the performance advisor. And what it does is it looks at the queries that we run the most and are the slowest and recommends indexes to make them faster.
So we ran it against our application, and it found that we run this query doing a descending sort on the creation date field in the post collection, because we're trying to list the most recent posts. And so it recommended that we create an index, a descending index on the creation date field.
So when we clicked that more info button, it gave us this little snippet to actually paste in the Mongo shell to create those indexes pretty easily.
We might have to actually open a terminal.
Let's say that we take all the performance advisor's advice, and the performance advisor is empty, meaning that it doesn't detect any slow queries.
So this means we pretty much exhausted our options in terms of improving performance by just adding indexes. The time to get more faster hardware may be imminent.
So we might want to take this moment to look at the metrics again to find out if hardware is in fact the bottleneck for our database's performance.
That is a graph of our RAM usage.
Looks like that it spikes up to almost 90% sometimes, and this might be a good indicator for us to actually move off of the free tier. So in general, we have these hardware metrics, and if we're reaching 100% on any of these, or our operations are getting queued faster than they're getting executed, it might be a good indicator that it's time to move onto a more powerful machine. In particular, the RAM utilization is our most common bottleneck that we see for customers, so that's a good thing to keep an eye on. Now let's take a look at how to do this in Atlas.
Okay, so again, we click Edit Configuration, and then we click, we choose the new instance size that we want, and we click the green button. And then we wait a little bit, and we'll have faster hardware.
And all of our issues were solved with our hardware. Fast forward to 2030, and scooters have actually become an international phenomenon. They're in everybody's hearts, and our app has basically taken the place of Facebook and LinkedIn and equestrian singles combined.
And even we have upped the scooter ante again. I now have a rocket scooter.
And I can now use a scooter to phase through time and space.
And this is our app. We have users in all over the world. Here are some in France and Australia.
But a new problem has arisen as a result of our fame and fortune, and it's that users in France are actually reporting slow reads and writes. This is because all of our data is still in North America, and that adds an extra 70 milliseconds to any reads and writes that French users may be performing.
Who has that kind of time, really?
Not I. So to set up the solution to this problem, let's talk about what sharding is. So you all remember the replica set that our database is already. It's got a primary node and 2 secondary nodes for consistency and durability. With a sharded cluster, we have a bunch of replica sets, each of them maintaining just a part of the data set instead of the whole data set. What's nice about this is that it has all the consistency and durability of a replica set, but writes can happen on more than one node. And speaking particularly to our problem, we can imagine that each of these shards or replica sets could be in different parts of the world. So our application connects to our MongoS, or sharding router, which coordinates reads and writes to make sure that all the documents go to the right node.
Partitioning is achieved with a thing called a shard key. Each shard owns specific ranges or chunks of the shard key, and all operations on documents whose shard key fits within those range happen on the corresponding shard.
So we can ensure that users' data goes to the data center that's closest to them by using this shard key.
So say we have one shard in North America and another in Europe. We can set things up so that all the users who live in the Western Hemisphere have their data stored on the first shard, and users who live in Europe have their data stored on the second shard.
As we said, shards own certain ranges of documents as specified by the shard key. So we can imagine that if we add a field to the shard key location, we can have control over which documents go to which shard, especially if those documents are location tagged.
And we can restrict which shards can store which documents or which ranges of the shard key using something called zones. So, for example, in this case, we'd set up a zone for North America and say that all documents which have Canada as the location part of the shard key are part of that zone. And we could say something similar for all documents which have US as the location portion of the shard key. And then you could set up another zone for Europe and say that all documents which have like France as the location portion of their shard key belong to that zone, and do this for however many countries. And then we would associate each shard with the zones that we just set up. So since shard 1 is in North America, we would associate that with the North America zone, and similar for shard 2 in Europe. And this would give us what we want. All users whose data, or whose has US and Canada as the location part of their shard key would be on shard 1, and similar for shard 2. And so this would give us low latency reads and writes in both locations.
So how do we turn our replica set into a sharded cluster? Well, we already have our one replica set. So what we could do is spin up another replica set, which would be the config server, which contains all the metadata for which shards would have which documents as specified by the shard key. And then we'd spin up a MongoDB server or a sharding router and point that to the config server, and then point that to our replica set, which we can now think of as a shard. We can repeat this process by spinning up another replica set and pointing the MongoDB to the new shard, and let the chunk balancer do its thing by performing chunk migrations based on what's specified in the config server. So now we'll show you how to do this in Atlas.
I really hope we're not going to just play these people another video.
I can't hear you, Ian. I'm in a shard across the Atlantic Ocean. All right, so we're going to click Edit Configuration again and get taken to this page. This time we're going to turn on Global Cluster Configuration, which is a new feature in Atlas. And we can configure the template ourselves by adding whatever zones we want. For instance, if we just want to add a zone in Paris, we can go ahead and add a zone and change the preferred region to be the data center in Paris. So that would solve what we have right now, but let's say that we want to actually improve performance for all of our international users. We can go ahead and click one of the predefined templates, Excellent Global Performance, and we kind of set up a template for you, which kind of puts zones in different regions and makes sure the preferred regions are well spread out. So once we apply these changes, there's still one more step, and the UI will point you to where exactly this will be. But you've got to finish configuring your shard key. So you're taken to the collections page of the cluster, and we can add a database and a collection, and you can see that that first shard key right there, the first field of that shard key is location, and that's locked in. So that has to be part of your shard key. And you can add whatever you want as the second field for your compound shard key.
Keep in mind that you can't change your shard key, so think very carefully about when you do this, and don't put all of your stuff in one collection. Okay, so some of you might be asking yourselves if you can use this global rights feature to achieve compliance with data privacy regulations like GDPR.
General Data Protection Regulation, or GDPR, recently went into effect in the EU and pertains to all EU citizens. Part of the law specifically restricts where data about EU citizens may live.
Just because you use this feature, or zone sharding in general, will not make your application GDPR compliant, though. Achieving compliance with these kinds of laws is a multifaceted task and involves your database infrastructure as well as your app's functionality, which we can't control.
So we've been told that this is kind of a tricky topic, and we're not lawyers, so we won't say too much more about GDPR compliance with regards to this feature. But if global clusters is something that you want to include in your GDPR compliant app, then that's something that you should talk to about with your lawyers.
Wow, that was a quick 12 years.
Indeed.
Let's go over the hurdles that we've overcame. So first, we had no money.
But luckily for us, the free tier was free, so we didn't have to deal with that.
But we quickly outgrew the free tier.
But the Atlas UI made it pretty easy to move off of the free tier into other hardware, a single tenant cluster.
But then we had an outage and lost a bunch of users.
to prevent this from happening again, we configured our cluster to be cross-region.
But then we experienced performance issues again.
But we added indexes to speed up performance and moved into more powerful hardware.
And then again, we received complaints about performance from users overseas.
But global rights sharded clusters on Atlas made it easy to overcome this as well. So in conclusion, we don't want you to be killed by your success.
At several points, we had to completely change our database infrastructure in order to not be killed by our success. If we'd been managing this all ourselves, we would have had to hire a team of DBAs and deal with a lot more human error.
Instead, we were able to build our Scooter empire with just ourselves and an Atlas account. Yeah, it was great.
When you showed up for this talk, you probably didn't think that you just watched us click a bunch of buttons.
Actually, just recordings of us pushing buttons.
Okay. But we are genuinely excited about the fact that Atlas prevented our app prevented us from being killed by the success of our app.
Thank you for listening. We won't be taking questions right now, but we will be outside scootering around, so feel free to flag us down if you have any questions.